Okay, good morning everyone. So kita start lah ya. Chapter 8 part 2. This is the last part for this part. After this nanti I bagi you Google Form untuk you pilih topik form 4 yang you nak ulang kaji. Selepas habis kita punya chapter 8 lah ya. Okay, our learning standard for today's lesson, solve real life problems through mathematical modeling, which involve the following function: linear, quadratic, exponential, and communicate the mathematical modeling process implemented. Okay, kita nak tengok 3 contoh lah for linear, quadratic, and exponential. So this is for linear real life problem. Amin travel 405 kilometer on 45 liters of petrol in his car. If Amin wishes to go to a place which is 198 kilometer away by car, how much petrol in liter does he need? Solve this problem through mathematical modeling. Bila soalan tu minta solve this problem mathematical modeling, macam biasalah kita ada 6 step tu. Ingat lagi kan? So the first one, identifying and defining the problem. Okay, determine apa yang kita nak cari sebenarnya. Determine the volume of petrol required for 198 kilometer. So we know that the farther we travel, the more petrol we require. Thus, the amount of petrol varies directly with the distance we travel. Ini linear lah. Lagi banyak, lagi itu the more farther we travel, the more petrol we require. Okay, second step, making assumption and identifying the variables. So assume that the driving speed for both 405 km and 198 km route are the same. Sebab speed ni pun mempengaruhi petrol. Maksudnya lagi laju kereta you bawa, lagi banyak petrol diperlukan. So let X, ini variable lah, represent the distance travel and Y represent the amount of petrol required. So Y varies directly with X. Ini you dah belajar dah. Hence Y equals to KX, where K is a constant. So step 3, applying mathematics to solve problem. Substitute Y equals to 45 and X equals to 405 into Y equals to KX. Yang ni kita nak cari K. So K equals to 1 over 9. Therefore Y equals to 1 over 9 1 over 9 X. So this equation describes the relationship between the amount of petrol required and distance travel. So when X 198 kilometer, Y equals to 22 liters. Hence, 22 liters of petrol is required to travel 198 kilometer. So this is step 3. Next, step 4, verifying and interpreting solution in the context of the problem. We may not be able to use the linear function model Y equals to 1 over 9x in all situations. For example, if the 405 kilometer route is through town and cities and the 198 kilometer route is through highway, thus the car will use up petrol as a faster rate in the first route compared to the second route. When this is translated to the real world situation, the linear function model obtained is not suitable to solve this problem. So refining the mathematical model, step 4. In this problem, we are not able to refine the model due to limited information given. So reporting the finding. Ini yang keempat. Step 4, step 5. This is the last step. Reporting the finding. Report the finding of the problem solving based on the interpretation of solution as shown in the preceding section. Okay, ini contoh untuk soalan linear problem. Tak tahu tahulah soalan tu nanti dia nak suruh you buat full ke 6 step ni. I don't think so. Dia tak akanlah suruh sebab berapa markah dia nak bagi ni. Kan kalau section B, total mark adalah 9. Kalau tengok pada jalan kerja ni yang 6 step ni, rasanya markah dia lebih daripada 9. Ada satu lagi section which is section C. Kat situ ada 15 markah. Tapi dia tak boleh, section C tu soalan dia tak boleh 1 bab sahaja. Dia mesti lebih daripada 2 bab. So I tak rasalah dia akan tanya satu soalan ni lengkap. Kena kena bagi semua step ni 6 ni lengkap. Rasanya tak mungkin lah. Mungkin dia akan suruh you buat 1 dan 2 atau 1, 2, 3 macam tu lah. Sebab dia tak boleh tanya minta you buat 4, 5, 6 terus, tak boleh sebab dia mesti kira daripada awal kan. So tak mungkin lah dia tiba-tiba tanya yang belakang ni. Kecuali kalau dia dah bagi dah step 1, 2, 3, lepas tu dia minta you bagi step 4, 5, 6 mungkin. Soalan dia tak sure macam mana nak keluar ni. Sebab this is first time. So ini adalah example untuk quadratic. Okay, the diagram below shows the cross section of a river. A hydrologist measures the depth of the river y meter, okay, y meter at different distance x meter from the river bank. The result obtained are given in the following table. Okay, ni table dia lah. This is X, this is Y. Maksudnya lagi, kalau tengok kat sini, lagi jauh daripada river bank, lagi dalam, tapi kat sini dia dah rendah balik. Okay, show how the hydrologist uses the data above to determine the depth of the river through mathematical modeling. Okay, first step, identifying and defining the problem. How to determine the depth of the river. Making assumption and identifying the variables. Assume the river is the deepest in the middle, with the depth increasing to 0 at the edges. The 2 variables involved is in this study are the depth of the river, y meter, ini untuk identifying the variables, and the distance from the river bank, x meter. So step 3, applying mathematics to solve problem. Write the distance from the river bank and the depth of the river as a set of ordered pair, xy, and draw a graph for the data. So graph dia akan jadi quadratic. The data seem to rise and fall in a manner similar to a quadratic function. Okay, the graph drawn shows the curve of the best fit and resembles the graph of a quadratic function. In mathematical modeling, to represent the actual situation, the approximate value is used. Based on the graph, the depth of the river is 3 meter when the distance from the river bank is 15 meter. Ini anggaran lah. Maksimum dia 15, kedalaman dia 3 meter. Okay, verifying and interpreting solution in the context of the problem. Step 4. So determine the related quadratic function of the form y equals to ax squared plus bx plus c. Ini adalah quadratic function. Determine the constant a, b, c by substituting any 3 data. For example, 0, 0, 25, 1.7 and 30, 0 into the equation. So substitute all the values. So since C equals to 0, the system of two linear equation in two variable is, so ini daripada yang atas ni, so kita akan dapat macam ni lah. Equation 1, equation 2, lepas tu this one use substitution method. Akan dapat value A and B. So hence the possible quadratic function y equals to negative 0.0136x square plus 0.408x. Okay, ini adalah quadratic function yang kita dapat selepas substitute values. So untuk dapatkan x15 ni y dia berapa, so substitute into the formula the value of x which is 15, then here y equals to 3.06, approximate to the answer obtained from the graph. Tadi dekat graph pun kita dapat 15 tu 3.3 kan, so lebih kurang lah. Maksudnya kat sini function yang you buat ni ataupun nanti kalau adalah soalan macam ni, betul lah, function tu betul. Tapi untuk soalan inilah, bila kita nak refining the mathematical model, we assume that the river is the deepest in the middle. This may not be true for some other rivers. Maksudnya yang kita buat tadi itu mungkin sesuai untuk soalan. Tapi untuk river lain, tak sure. A new model will be needed if we have new assumptions. The answer will be more accurate if more data have been collected. So last step, reporting the finding. Write a full report following the above modeling framework structure. So ini contoh kedua untuk quadratic problem. Next kita nak tengok exponential problem. Ini contoh, compound interest is interest that is calculated based on the original principle and also the accumulated interest from the previous period of saving. At the beginning of a year, Mr. Gomez saved 20,000 in his saving account with an interest rate of 4% per annum, and the interest is compounded once a year. Derive a mathematical model for Mr. Gomez's total saving after 3 years of saving. Solve this problem through mathematical modeling. Okay, step 1, identifying and defining the problems. Mr. Gomez is given compound interest which is compounded once a year. His principal 20,000, the yearly interest rate 4%. So derive a mathematical model for Mr. Gomez total saving at the end of the years. Ini yang kita nak cari. So step 2, making assumption and identifying the variables. Assume Mr. Gomez did not withdraw or raise his saving throughout the period of saving. The variable are principal amount, RMP, yearly interest rate, R, number of time of interest is compounded, N, and time, T years. Variable ni semua you dah belajar masa form 3. Chapter apa Tak ingat lah, siapa ingat?
3.
Chapter 3, consumer mathematics tu. So maksudnya untuk variable ni boleh guna yang you pernah belajar lah. Tapi kalau guna variable yang lain boleh tak? Macam contohnya you nak guna for principal, you nak guna RMR contohnya. Kat sini nak letak Q, kat sini nak letak contoh A, contohlah you nak letak variable yang lain. Yang tu kena boleh, tapi kena hati-hatilah tengok pada soalan. Kalau soalan tu memang dah menyatakan variable, kena guna pada soalan. Tapi kalau soalan tu tak menyatakan variable, boleh letak ikut suka variable ni. Depend ya, depend pada soalan. Kalau dalam soalan memang dia dah letakkan variable, tiba-tiba you tukar variable kat sini, situ dah salah lah. Okay, step 4. Ni step 3. Applying mathematics to solve problem. Keep in mind that when calculating the compound interest, each year we have 100% of the principal plus 4% of the previous balance. We construct a table as follows. For the first year, principal 20,000, interest received darab dengan 0.04. So principal plus interest inilah. So this is amount of saving for the first year. This one for second year, third year, fourth year, fifth year. Okay, verifying and interpreting solution in the context of the problem. Based on the table from the previous slide, at the end of the year, the amount of saving is a power of 1.04 times the principal, 20,000, and the power correspond to the number of year of savings. We can generalize this pattern to a mathematical model by letting P represent the principal of the saving, T represent the number of years, and R represent the yearly interest rate. Hence, the mathematical model is A, ini adalah amount of saving after T years, equals to P bracket 1 plus R close bracket T. Not that 1.04 equals to 1 plus 0.04 or 1 plus R. Okay, this mathematical model is an exponential function that allow us to calculate the amount of saving if the interest is compounded once a year for 30 years. The graph on the right shows the exponential function AT equals to 20,000 in bracket 1.04 to the power of T. The graph of the amount of saving after T years shows an exponential growth as time T increases. So ini adalah graph exponent or exponential function. So the mathematical model is used for annual compounding. In reality, interest is often compounded more frequently. For example, compounded semi-equally or quarterly. So if the interest is compounded monthly, the interest rate R is divided among the 12 months because 1/12 of the rate is applied each month. The variable T in the exponent is multiplied by 12 because the interest is calculated 12 times in a year. Hence, the mathematical model become, ini adalah formula untuk compound interest. Biasanya you tak, kalau form 3 you guna AT ni adalah MV kan. Ni kita ikut pada soalan lah. Ni adalah value of N, 12 ni. So in general, if the interest is compounded N time per year, the mathematical model is AT equals to P bracket 1 plus R over N close bracket NT. So ini sebenarnya adalah formula compound interest yang you belajar masa form 3. Ini lebih sesuai untuk digunakan untuk setiap problem. Sebabnya sini tadilah, in reality interest is often compounded more frequently. Macam contoh tadi dia kata once a year. Tapi sebenarnya in real life mungkin semi-annually or quarterly or kat sini compounded monthly. So depend pada bank. So formula yang sesuai adalah yang bawah ni lah. So reporting the finding, write a full report following the above modelling framework structure. Lebih kurang je ayat dia untuk yang reporting the finding ni. Okay, itu sahaja 3 contoh for linear, quadratic and exponential real world problem. So this is the process of mathematical modelling. Ini pun dah cerita banyak dah sebelum ni. Tadi pun kita dah buat dah 6 step ni. Maksudnya mesti ada 6 step. Start from identifying and defining the problems, making assumption, identifying the variables, applying the mathematical to solve problems. Ini kira-kira lah. Verifying and interpreting solution in the context of the problem. So refine mathematical modelling and reporting the finding. Kalau need to refine, pergi balik first step. Kalau tak perlu, so terus report. Ini soalan mungkin dia tanya apakah itu 6 step? Mungkin. Kan, apakah step pertama? Apakah step ketiga? Itu mungkin untuk soalan objektif paper 1. Mungkin dia tanya macam tu. So maksudnya kena tahu ke 6 step ni. So that's all. So this is your homework. Self-practice 8.1D. Kat dalam latihan ni ada 2 soalan. Boleh tengok. 2 soalan ni kena buat daripada first step sampai step yang terakhir. Bila soalan tu solve this problem through mathematical modelling, maksudnya kena buat 6 step tu lah. Okey, ada soalan tak? Okey, kalau tak ada, itu sahaja untuk hari ni.
Thank you, teacher.